Hello, everybody. Welcome to this lovely Wednesday afternoon or whatever time it is in your location in the world. Thank you so much for joining us. We'll be going through some information on biosecurity and focusing on the importance of digital information security. So as far as navigation of this platform, you'll see some options for chat and questions and polls on the right side of your screen. If you click the caret, it will drop down and you can see where you can enter a question into either the questions box or into the chat. And we'll be monitoring those during the presentations so that we can answer any questions as we go along, or perhaps shift those to the end of the conversation if those are going to possibly come up later in the time. You'll also see the polls option. And if you drop down the polls, it should give you a prompt as we go through. And feel free to answer that poll and we'll get a little bit of interaction going. So the webinar and recording will be made available on the Merrick website after we finish up this webinar. And we look forward to hearing from you. Next slide. So as a practice, we'll go ahead and send out a poll so everybody can practice using this. I'm going to go ahead and launch the poll now. And we'll give it a good 30 seconds so that people can figure out where that poll is on the side of the screen. Looks like we're getting more people rolling in. All right, I think we've got most folks, so we'll go ahead and close that poll. And it looks like most people are in need of a vacation. I certainly appreciate that. Though every day on this side of the dirt is a good day. So I appreciate you joining us. I know it's long days for most folks right now, especially when we're talking about digital information and using platforms over the web. So this is the team that'll be talking with you today. I am the lady on the left. I'm Lauren Richardson, Director of Science and Technology Programs for American Company. Got a background in veterinary medicine and public health, and here at Merrick, I focus on operational planning, risk assessment, training, and other areas of life sciences operations. Nick is the fellow who currently looks like he is in a DJ booth. He's having a little bit of an audio issue with the weather today, so appreciate you finding a makeshift space where you could get a better audio. Nick is a senior technical subject matter expert for security, biosecurity, and cybersecurity here at Merrick. And prior to joining the private sector, Nick was a special agent in the Federal Bureau of Investigation, where he served as a weapons of mass destruction coordinator, an undercover agent, and a lead investigator on numerous national security and criminal investigations. And we also are joined by Dr. Sterling Zawaya, who is over there on the right side of the top of your screen. Sterling is the founder and CEO of GeneInfoSec, which is a company that is developing technology to protect genetic information. Dr. Zawaya has a PhD in genetics and a diverse background in genomics, bioinformatics, and biochemistry. He's also currently a member of Merrick's Consulting Advisory Board. So thanks so much for joining us today. Next slide. Thank you for attending. We're excited to present this material and for the opportunity to connect. We hope that this session is informative and insightful. If you have questions, please don't hesitate to reach out to us either through the chat or questions functions, or at the end, we've also got some contact information via email. We want you to get as much information as possible from this experience, and if there's something we didn't cover or you'd like to know more about, please let us know and we'll cover it in a future session. Next slide. All right, so here's the agenda for today. First, we'll talk about the foundation of understanding fundamentals of biosecurity and biorisk management. Then we'll review the different components of biorisk management. Then we're going to go into the current landscape of information security threats, and that's when Nick will take us down to that specific area. And then Sterling will take us into a deeper dive into genetic information security. And then we will talk about reviewing methods for mitigating biosecurity threats and risks. Next slide. So we'll start off with fundamentals of biosecurity and biorisk management. So Well, I always like to start off with definitions so that everybody can be on the same page. A biorisk is an effective uncertainty expressed by the combination of consequences of an event, including a change in circumstances, and the associated likelihood of occurrence where biological material is the source of harm. So I think everybody's familiar with a risk, and when we're talking about a biorisk, it's pretty simple. And so it's all of the harm that is caused by the consequences associated with biosafety and biosecurity. The harm can be the consequence of an unintentional exposure, an accidental release, loss, theft, misuse, diversion, unauthorized access, or an intentional unauthorized release. And if you are looking for more information on this, you can look at the ISO 35001 standard for 2019. Next slide. Biorisk management is the coordinated activities to direct and control an organization with regard to biorisk. So it's how we address biorisk at the institutional level. And a biorisk management system is one that is a system or part of a management system used to establish biorisk management policies, objectives, and processes to achieve those objectives. So while biorisk management is the activity of dealing with biorisk, the system for biorisk management is the way the organization is actually going to do it. Without a detailed biorisk management plan, the biosafety and biosecurity plans and policies, an organization can't really create biorisk management SOPs for people to be trained on and to follow. This is also really important in terms of the impact of biosafety in a laboratory. Without a well-designed system, components of the biosecurity plan, policy, or SOP might negatively impact biosafety in a laboratory. And so we can avoid this by planning through integrated biorisk management. Next slide. So this slide deck, this slide that you see here is an image taken out of Dr. Burnett's book. Dr. Burnett is with the Life Sciences Division. He is the new Vice President of Life Sciences at Merrick. And it shows a really interesting way of viewing biosafety and biosecurity for total biorisk management in a laboratory. And the thing I like about this particular image is that it shows directionality. So on the left side of the screen, you can see the components of biosafety. This is where I think most folks are pretty familiar with working in a laboratory. We think about the risks that come from the biological materials. So things that might happen during exposure to an agent, aerosol generation, flaws in the facility, poor training on the part of the employees, and poor management practices. And we assess those in terms of risk assessment. On the right side of the screen, you see biosecurity. This is really in the realm of threat assessment. And so threats to that valuable biological material include anything from a natural disaster to a crime or intentional impact. Across the board, we look at vulnerability assessment, and that shows an end-to-end look at the potential vulnerabilities in the system. So this is a pretty broad strokes diagram, and it's not intended to be comprehensive, but to show the basic relationships and the directionality of threats and risks to biological material. At the origin of any of these things is that agent or valuable biological material. And we call it valuable biological material because in different circumstances, this may look different. It doesn't necessarily have to be a dangerous pathogen. It could be any kind of material that is of biologic origin. And originally, this was animals. And so a lot of biosecurity is focused around animal security. Today, we're going to talk a little bit later about genetic information security. So just because it's not something that we consider dangerous doesn't mean that it's not valuable. But these agents do present risk to the user, to the public, to the environment, and the primary consequence may be an exposure. We mitigate risk by doing risk assessments and employing strategies and tactics to address those risks. On the biosecurity side, the direction of the arrows of the threats is toward the biological agent or valuable biological material. And so just remember that we're trying to mitigate threats that might result in access or release of those agents. Like the risk assessment process, we perform a threat assessment to identify and mitigate those threats. And coupled with both of those are the vulnerabilities. And so when we look at vulnerability assessments, we think about biorisk management, assessments, physical security, personnel management, material control and accountability, information security, which we're going to really deep dive into today, transportation security, incident and emergency response, and training. So if your facility is in a crime-free area, crimes might not be a threat. And if you have the industrial strength Titanic of labs, maybe hurricanes aren't an issue. So it really is going to be based on what your institution looks like and how you function in the environment in which you exist. All right, next slide. So biorisk management systems promote a synergy between biosafety and biosecurity. And so an example of this would be an integrated access control and identity management policy. So the properly designed system is not going to just prevent the biosafety and biosecurity from negatively impacting each other, but it can also give you opportunities to strengthen both of them. So with that integrated access control and identity management, you combine the access controls, so a pen pad or a card reader, with digital identity management systems. Both of those are biosecurity systems. And so in doing that, you can also strengthen your biosafety because you know who is in the lab and potentially could have been exposed or affected the last time that they entered the facility. You can also trace those people's interactions with other personnel on the premises and identify any modifications to the procedures that are needed to increase social distancing in the area of COVID-19. So this is something that is originally intended to be a security function, but it really serves holistic biorisk management. So if an employee or recent visitor was exposed to a biohazard or contracted COVID-19, biorisk management, biosafety, biosecurity, or office manager would want to know when they came on, where they traveled, and who they met. And so we can then trace the exposed or infected person's presence and identify anybody else who may have been in their path. So it offers a lot of different opportunities. When we take access control and credentials and we integrate it with identity management, you have a history of the physical presence of the scientific employee. On any day, you know where they were, and it makes it a fairly robust system of biorisk management. You can also integrate this with visitor management, and so the same tracking capability can be used for an outside consultant who might come into your facility to do an assessment under a temporary access control. So that's just one example, but we'll go on to the next piece. Take-home messages for biorisk management. It's important to formally structure your biosafety and biosecurity practices into biorisk management plans, policies, and SOPs, regardless of the size or complexity of your program. Biosafety practices directly impact biosecurity, and in turn, biosecurity practices impact biosafety. Next slide. So, what is biosecurity? Definitions again. Laboratory biosecurity is the institutional and personal security measures designed to prevent the loss, theft, misuse, diversion, or intentional release of pathogens and toxins. Another definition is practices and controls that reduce the risk of loss, theft, misuse, diversion, or intentional unauthorized release of biological materials. So both of those definitions show common aspects of the same activities, and it's worth noting that the bottom definition is recent and in an international standard, while the top one is guidance. I think we can say that these are becoming codified and recognized as important. Next slide. What is biosecurity? So protection can extend beyond the pathogens or toxins and may include other assets of biological nature, value, and significance. So all of this encompasses valuable biological material. This does not mean that the asset is inherently dangerous, hazardous, or even biological material. So today we talk a lot about an asset being biological material and associated data. Sensitive information associated with the laboratory could be all considered under the umbrella of biosecurity. Next slide. So a lot of folks point out that this just sounds pretty familiar and maybe is a part of general security. What makes biosecurity different or unique from standard traditional security? Assets, so the biological materials, are difficult to detect. They're really small and they might not be picked up in certain instances. or they might not be picked up at all until something happens as a consequence of them. A risk is realized. Some can reproduce under the right conditions, and you only need to remove from the laboratory a small amount. So this is a type of asset that propagates on its own or with a little assistance. Nucleic acids, which is something we're going to focus on in a little bit, are inherently and fundamentally benign, but that doesn't mean they don't have value. And then who decides what info can or should be released? Often this isn't who you think it is. And understanding who has access control to that information associated with the materials is really key in making sure that you have the right security controls. So far, protection has been the knowledge that's necessary to work with these materials. What does that mean? The barriers for entry into the life sciences activity has been the expertise that's required to work with those materials, but that keeps lowering year after year. And so the ability for unqualified or malicious individuals to conduct that activity is growing. Next slide. So the concept review. Biosecurity is concerned with mitigation of threats that can lead to the loss, theft, misuse, diversion, or intentional release of dangerous biological agents or other biological assets. We go here beyond the normal definition in the security world of threat, which is often considered to be a person, to include also hazards. So when you're thinking of threats today, think of threats and hazards as one and the same. This contrasts with biosafety, which is also concerned with mitigating risks associated with unintentional exposure or release of those agents. Next slide. All right, a little bit about assessments. So I'm going to go ahead and launch a poll. Give me 1 second. And this should be launching. So what was the last time that you examined your facility for biorisk vulnerabilities? Starting to get some responses coming in, so hopefully that's working. If you've snoozed, then hop back online and answer a poll. All right, we'll give it a couple more seconds. Still getting some responses coming in. All right, I'm going to go ahead and close the poll. It looks like about half of the folks online don't know or have never really examined this, and about a third said within the last 6 months, and the rest between 6 and 18 months ago. So that's a pretty fair smattering of the different possibilities. And that might be a result of who's on the line, but I am glad to see at least a third of the folks have looked within the last 6 months. All right. So the foundation of a biosecurity plan, policy, and the SOPs that stem from those is the assessment. And you can see our little image over to the right. How can you prepare for a hazard or a threat if you don't first identify it? Next slide. So in terms of components of biosecurity assessments, we can better understand those assessments by looking first at the biosafety. And so this is going to be another diagram that you'll see, but it's pretty helpful in terms of thinking this through. This is concerned with identifying biohazards and concerned with the unintentional exposure or release. So the impact of that agent or biological material on other people. So those create a risk that results in a consequence. And as we previously discussed, this is really in looking at the contributions of the agent to that risk of harm. The assessment is going to evaluate the agents as well as the practices and controls in the laboratory to determine if the appropriate measures are in place and are actively being taken to mitigate those biohazard risks from the agents. So for an example, biological agents in a laboratory are designated through biosafety standards to require a biosafety cabinet. And the biosafety assessment then identifies if the laboratory was using the cabinets for those agents, and if the cabinets were the proper models for the agent, and if they were properly maintained, and if people knew how to use them. So it really takes a look at not only are the appropriate controls in place, but are they being monitored, are they being maintained, and do people understand them, and are they able to functionally use them? When we're looking at a risk assessment for biosafety, we often focus on the intrinsic properties of the agent itself. And those things might be, is it an aerosol transmissible? What's the infectious dose? How do you inactivate it? Is it something that's heat tolerant? So the characteristics of that agent that allow us to put in place either controls or mitigations to prevent those risks from being realized. Next slide. Conversely, a biosecurity assessment is concerned with threats and vulnerabilities. And so those are threats to the biological material. So that's the agent or associated data and the vulnerabilities to those threats. This is concerned with the threat identification and an intentional exposure or release. And this also looks at the biological agent's properties, but in a different way. What's the monetary value of the agent or its associated data? Is there a potential for weaponization or dual use? Is this something that could be considered intellectual property? Just because it's not terribly dangerous doesn't mean it doesn't have value and doesn't have the ability to harm. Next slide. So continuing on that piece, the threats can come from many directions. It could be a malicious insider, a negligent researcher, state actor, so that's a government agent, or a non-state actor, so a criminal or a terrorist. And it's very important to understand the potential threat sources. These are not going to be the same for every institution, for every agent, for every type of material or locality. An example for this would be a potential threat to a community laboratory is the exploitation of the laboratory by a malicious actor to create something that is harmful that they intend to release. To evaluate the actual risks of the laboratory to that threat, you would do a vulnerability assessment that would then be paired with that threat assessment. Next slide. So when we combine those two things together, we see the complete biosecurity risk assessment. So that risk assessment zone from the threat source all the way through the agent. Next slide. And then we see the biosafety risk assessment zone, which takes us through the intrinsic properties of the agent through the consequences. Once you combine those and pair them with both the threat and risk assessment, you see a complete picture of biorisk. And then you can use that to craft more comprehensive or revise biorisk management plans, policies, and SOPs that are integrated and they support both biosafety and biosecurity synergistically. And they mitigate problems that arise when biosafety and biosecurity are created separately. Next slide. So the take-home message in terms of assessments, they're the cornerstone of any biosecurity program. And that process is going to help reveal the specific mitigation measures that are needed for each specific location. As we mentioned before, how are you going to prepare for hazards or threats if you don't know what they may be? All labs, regardless of whether they're a small mobile lab or a multi-building compound, if you're working on mid-level hazards or high-level hazards, anything from SARS-CoV-2 to Ebola, or low-level hazards like a gene synthesis lab, you should have the same threat and vulnerability assessment process. Next slide. So I'm just going to run through the components of biosecurity, and we'll not belabor some of these initial parts, but we'll deep dive into that information security piece. So starting with physical security, this is the physical infrastructure and security procedures associated with biosecurity. It's not one size fits all. So on the left, you see Fort Detrick, which is an Army Medical Command installation in Maryland. And on the right, you have a DIY biolab in GenSpace, and that's in the middle of New York. And so we usually think of this in terms of gates, guards, and guns, but really this is access control or mechanisms for physical security to allow only authorized individuals access to certain areas. Next slide. Take-home message. You don't have to conduct science in a military installation or high containment lab for physical security to be important. And if you have physical security measures that everybody ignores, you have a false sense of security. So an example of this would be something like you've got doors that lock, but you don't ever lock them and you don't know who has the keys. Next slide. Personnel management. So I think this is probably the hardest topic for most institutions when you think about it initially. And I think in terms of what could potentially be one of the more difficult topics in general. So this is concerned with people rather than things. And so we consider certain aspects of personnel management. Are the number of people authorized to access restricted materials kept to the minimum needed that are necessary for those requirements. And are personnel suitability assessments conducted and used to determine who should have access to those pieces? How do you monitor individuals in escort status? And then how do you continue to monitor those pieces even after the initial hire or the initial screening to let them in the building? Next slide. So does your organization have a personnel reliability program or a PRP? This is a formal program that's designed to ensure that everybody who's authorized access to the sensitive materials and everyone authorized to escort or supervise people with that access meet the highest standards of integrity, trust, and personnel reliability. There's a lot of conversation that surrounds this topic, and it can be difficult to create what most people call a culture of security and safety. And so one of the things that's most important is knowing your people and understanding what they normally do and setting expectations for behavior. Next slide. Take-home message. The principles of personnel management should be built around codes of conduct for each organization, even if you're not using a personnel reliability plan. Doing so is going to provide every organization with the confidence that everybody who's involved in science is able to support each other for safe and secure science. So principles of personnel management might include adherence to procedures, open communication, conflict management, avoidance of blame or retaliation, respect for individual privacy and dignity, and probably most importantly, empowerment to stop work in the space if it's unsafe or unsecure. And this should be in every organization, regardless of whether or not you have a formal PRP. Next slide. All right, material control and accountability. This is also concerned with physical assets to be protected. So things that you might want to consider are, is there a policy that defines what's sensitive or restricted? Are there policy and procedures for inventory of those materials? Have all of these materials been identified and located? And is there a policy and procedures to understand sensitive or restricted materials is consolidated to the maximum extent within the constraints of the facility? So the fewer areas that you have access to those materials, the easier it is to monitor and secure those materials. Next slide. The principles of this are important even if the setting doesn't have especially hazardous or dangerous assets. From an institutional standpoint, it doesn't matter whether it's dangerous, it should be handled with care. So employing a comprehensive program in an organization will make more efficient use of their assets because they're going to have a much better understanding of where they are and how they're used. This is going to lead to a much lower risk of loss to those assets because you know where they are. Next slide. Transportation. Transport is the sending and receiving of materials, and this is one of the most common areas where a facility will engage that. So most often it's getting materials into your laboratory, sending out items to other facilities, or even just receiving samples. Agents are often most vulnerable to security threats during transport, and so you have to pay special attention to it. There should be a policy and procedures for controls of restricted materials and movement between restricted areas or while in shipping and receiving areas. And individuals who are responsible for this movement within the facility should be required to complete security and background checks. Administrative approvals should be required for internal and external transport of sensitive or restricted material. Next slide. This is the component of security most likely to be missing from an organization security program because often it doesn't seem to be captured in the actual program. It's easy to understand because most places don't have hazardous biological material that they send and receive. It's really important that you don't ignore it though, because proper security and safety protocols for shipping and receiving will account for that kind of black swan event, an event that comes as a surprise, something like a suspicious package being received. Next slide. All right, information security, the guts of where we are. Information security is associated with biological agents can be as sensitive as the agents themselves. And that's why often we talk about valuable biological materials and associated data. The important point here is that is all wrapped into the same piece of important material. And so Nick and Sterling are going to go into this topic in more detail. Next slide. What do we need to consider when we're trying to secure information in general? We've got confidentiality, so can the data be stolen? Availability, can you block access to the data? And integrity, can you trust the data? Poor confidentiality causes data loss, and that can lead to a range of damage from personal privacy to loss of intellectual property. And availability is essential for operations. If your lab has poor IT security, your operations can be slowed, stopped, or damaged. Integrity of your systems is required for confidence in your operations. If your lab equipment can be modified to harm data integrity, or if the storage of your samples can be damaged, if you can't trust your data, then customers can't trust your institution. Sterling is going to go into this piece a little bit later in the presentation, so I will not steal his thunder or try and step out of my window of knowledge. Next slide. Take-home message here. Principles present in information security are probably most applicable to everyone inside and outside of the laboratory, and cyber attacks are the most consistent security threat worldwide. So it's really important to be aware of what information that they present to the public. The best way to address these threats is through cybersecurity practices, and we're going to talk about that in a little bit. So up until this point, my goal was to give you a bit of a framework and a context for the information security as part of an overall biorisk assessment and management program. So I'm going to hand it over to Nick to talk a little bit more in detail.
Thank you, Lauren. And thank you to everybody for joining us today. And I'm going to spend a little bit of time talking. We're going to go a little narrower now, and we're going to talk about some information cybersecurity threat models. We're going to talk about first some incidents that have occurred, some breaches that have occurred over the last several years, some very recent as this year, as well as some of the larger ones that have happened in recent years that I think illustrate what we're going to talk about second in even more detail, which is the common methods that bad actors will take, malicious actors will take when attempting or conducting hacks and intrusions on your networks. As a WMD coordinator in the FBI, I worked several investigations where we saw pretty much every single one of these methods that by state actors and non-state actors. And the purpose of this section, before we move more deeply into Sterling's section, is to just give you a broad overview of what you could commonly expect from malicious actors and some of the potential damage that could be done, as we can see historically what's occurred. So first, I'm going to talk about a breach that I imagine most of you have heard of. If not, I'm glad you're hearing it now, because this is one of the biggest ones that have occurred, highest impact. And that was the Equifax breach. It's occurred in 2017. Equifax being a credit monitoring credit agency, and one of the three major credit agencies in the United States. And this attack was massive. The attackers gained unauthorized access via the internet to a single Equifax system, and that contained documents on what we say as at least 145.5 million individuals. This is so many individuals that it is reasonable for one to assume, if you're a United States, you're an individual in the United States, that your information was included. And one important point that I want to note right away is that, and this is going to be common, you're going to see this almost every time in all of these examples, is very, very common, is a malicious actor, a hacker group, an individual hacker, individual bad actor, they're not always going to go for that home run right away. In fact, most of the time they're looking for some very small inroad into your system so that they can then root around and look around for greater vulnerabilities, find the data or the material that they're wanting to exfiltrate from your system. And that's what happened here. The initial breach for Equifax actually didn't include that massive amount of millions of individuals, but it gave them the access to continue looking for systems to exploit. And over a 5-month period, they were able to do so and eventually get to that the treasure trove of personal data. So that's you're going to see that's a common thread that you're going to see in many of these examples is initial foothold into a system through something either minor vulnerability or maybe a major, but they'll continue to look for exploitation. Even if they find some valuable information right away, they'll continue to look for that. What was the impact? What was stolen? Well, in essence, everything that would be needed to steal an individual's identity. So this is full names, addresses, current and past addresses, date of birth, social security numbers, driver's license, right? Pretty much everything that Equifax has. And this is very harmful for a very specific reason that some of these are incredibly difficult, if not impossible, to change. So this isn't, and this is a common thread you're gonna see in these, and Sterling's gonna speak to this too. That once the cat's out of the bag, it's hard to put it back in, if not impossible. And in this case, in the United States, you might be able to get your driver's license changed. It's difficult, but you could do it, right? Social security number is nigh impossible to have changed. Date of birth, not possible to change, right? You're not going to move after this kind of a breach. Most people don't have the means to do that, so your current address is still going to be your current address. So it's tempting for organizations to look at what the potential cost is with a breach and quite frankly lie to themselves about what's going to happen because it's not always immediate financial impact on an organization. But if you think of it from the standpoint of whatever impact occurs, it's universally it's overwhelmingly not going to be something that's reversible, and that I think will start to give individuals in charge of security decisions at organizations the proper respect for security that they should take. Another example in this one, a little closer in the life sciences arena and not nearly as large, the case of Vitagene. Now Vitagene is different in that the issue with what happened there was from 2015 to 2019, they inadvertently left a large amount of data exposed online. So this was a little different in that they weren't actively attacked, but the effect can be very, if not identical, very similar. And a data breach included very similar information, customer name, email addresses, date of birth, but it also included health data. So information on doctors associated with their clients, genetic trait data, as well as the likelihood of developing medical conditions. So we're talking about personal health information. And so now we're stepping up some of the more specific type of information that's being lost. And now you might be tempted to say, well, Vitagene, they left that exposed. I would never do that. And I'm sure that's the case for the majority of organizations. But without conducting a proper and thorough security and mitigation assessment process, like Lauren talked about, you're not going to be able to know if that's true or not. And you don't want to make assumptions on this kind of thing. And so following the process of assessment and mitigation as a cyclical process that you're continuously doing on a regular basis, you're going to be sure that you're not going to fall to the mistakes that happen here with Vitagene. Another life science associated breach, which was actually quite massive, as many of you probably have heard of this one, is the Quest Diagnostics and LabCorp data breach. And this one shows an interesting aspect of cybersecurity, cybersecurity, in that the actual breach that occurred to both these are two separate companies, but the breach was actually a unified vulnerability in that these companies worked with a third-party billing collection firm, AMCA, and the third-party billing company was the one that was exploited, that had the vulnerability that was exploited. And that occurred for almost a year, from August 2018 to March 2019. And I wanted to bring this one up beyond just showing another example of the large impact that can occur. There's a lot of data out there that bad actors are looking to steal, but is also that it's very important for organizations to look at every single connected system that they have or data transfer that they have. it's very easy for a company to say, well, AMCA, I have this third-party organization, they're not part of our business, so we're not responsible for that. But that's not the reality. From a data standpoint, certainly from a bad actor standpoint, they don't care where. They don't look at companies. They don't look at org charts for the standpoint of what they're going to attack. They look at where the data is. And if you have data systems connected between two different companies, then from a protection standpoint, that's one organization, that's one system. Now, obviously, it's difficult when you have multiple businesses when you're talking about collaboration, but the thing that I want you to think about when you think about this example is if you have data transferring to partner companies, you need to ensure in your cybersecurity and your biosecurity systems and policies that it accounts for their security postures as well, that you allow for the ability to assess that their security protocols are in place properly as your own internal systems. The impact was massive. Over 19 million customers, and again, in this case, full names, date of births, and addresses, social security numbers again, patient records, as well as financial data. This was a very significant breach, and one that I think shows the importance of comprehensive assessment and mitigation, both in your own internal systems, but as well as any that are connected to external companies that you might work with. Another breach, Ambry Genetics. This occurred earlier this year in January. Not as large. When I say only, I'm really being facetious here. It was 233,000 customers. And in this case, it was a breach of the employee's email account. And this, I wanted to point this out because with the various examples we've done so far, you're already starting to see a breadth of initial exploitation. This one, employee email accounts, is very, very common. Phishing attacks where emails that try to get you to click on a link that's malicious, takes you somewhere where maybe you log into an account you think is real and it's not. Now you've given your credentials, or you open an email that has malware in it, or even as simple as an email that continues a dialogue with a bad actor that you don't realize, and they're conducting social engineering to get additional information. So this is an example of initial breach that was very common and maybe not as sophisticated as some that you're going to see, but it can have just as large of an impact. So I'll reiterate this as we go through this, but all of the different vulnerabilities, whether it's a very simple one that is very common, like phishing and email attacks, or very sophisticated ones like we're going to get to here in a minute, and Sterling's going to go into even more detail on. You need to have a comprehensive cybersecurity and biosecurity, biorisk management assessment process to account for all of them. There is no other way to account for all of the variables without having that thorough assessment and mitigation process. And then, as I'm sure have seen here, the type of data that was included is very similar to the others: customer names, medical information, information related to the services of the company, as well as, again, social security numbers. Now, I'm going to spend a little bit of time talking about more specifically state-sponsored threat models, and I'm going to use two examples that are very recent. There was an indictment from the US DOJ in July of 2020. Or indictment of 2 Chinese hackers, and I have the links here in the bottom. And when you'll be able to navigate to those once these are posted online, I highly recommend checking them out. We don't have time to go through the whole indictment. It's really, really, really long because these 2 individuals were associated with the Chinese government in part. Were conducting activity over 10 years. And targeting a whole host of high technology industries, including life science, several life science industries and companies inside all of these different industries. And what was very clear, and this is a very detailed indictment, I do highly recommend those of you who are interested to take a look at it, to read the details. But these individuals would look at any exploit that could be found, from a simple phishing or other email attack to very sophisticated zero-day attacks, which would a 0-day being an exploit in the code of software that is to that point unknown to the broad public, and those are rarer and very valuable because until they become known by the companies, they are not able to make patches to fix them. But so these individuals use the whole spectrum from very simple to very sophisticated attacks to get into a whole host of companies. And as I mentioned before, they would sit inside the network. This is so common. I saw this as an FBI special agent working against these attacks, working with companies in the life sciences that had been exploited. This is the standard practice, where they will initially exploit the system, and they will just sit and do their own assessment internally of the systems, of all the systems. Though they're very patient, especially these state-sponsored bad actors. They're very, very patient. Even if they initially find some very valuable material, they might not exfiltrate that information until they've more fully exploited a system, because one of the things they're going to be looking for is the ability to get back into a system in multiple ways. So while they might come in with some general information, like as we're gonna continue to talk about later, some FBI bulletins that indicates very strongly, in fact, I won't even say indicates, there is a huge amount of evidence to show that if you right now, if you're an organization that works with COVID-19, you are going to be targeted by these state-sponsored malicious actors. You should make that assumption. So they might target a company just generally because there was some media attention on some work that was being done by an organization. But once they have had any level of success with exploiting any system, they're going to continue mapping out your networks and finding out what else you do before they start pulling data, and they will make sure that they can do as best they can, pull out data without being discovered, so they can continue to exploit. Sitting on systems and continuously exploiting the organization's networks is a standard operating procedure for these types of state-sponsored bad actors. Another group, the Strontium group, this is a group that's associated with the Russian government, and it's fairly well known. It's been around for several years, and there's a report by Microsoft and the US DOJ that detailed specific operating procedures, specific activity over the last couple years by the Strontium group, and it's very similar to what I've been talking about with the Chinese-based groups as well as other groups. They're going to look for that initial entry, and they're going to sit. But what was a particular interest in the reports by Microsoft and the US government for the Strontium group's recent activity is their specific exploitation of what is often referred to as Internet of Things devices. Here is an example of several that were actually exploited by Strontium group, and that would be IP cameras and home routers, voice over IP phones, and office printers. Office printers are a very, very common vulnerability for exploitation. Networked office printers are. And Sterling's going to talk about this in greater detail, some of the reasons why, but this is, I would just like to really accentuate that when he does go into greater detail about the dangers of IoT devices or other devices that are like this, this isn't hypothetical. These vulnerabilities and the threats for exploitation of them are absolutely validated. We have lots and lots of examples of malicious actors utilizing these types of devices to get into systems. To be quite frankly honest, in my experience, I would say that they're probably their most desirable type of, a large number of these types of devices in a system is probably one of the most desirable environments for a bad actor, for the reasons Sterling's going to get into, but simply because many of them are not secure in their design. It's both hardware, firmware, and software. As I mentioned before, these types of devices, and specifically in the reports from Microsoft and the U.S. government, was showing what I was talking about, which is that they will look for as many of these types of exploitable devices so that they have multiple ways to get into your system. The reason for that is very simple. If they have one way in, like say a single office printer that's networked, and the company then gets rid of it just because it's at its end of life or any number of reasons, then they've lost their access. So one of the first things they're going to do is, after they've gotten the system, is they're going to look for as many other systems that they can get their hooks into, so that they don't lose their ability to get into the network at a later time. As well as some systems make it easier to hide the fact that you're pulling data out. That's also something that they're looking for. And as I mentioned, once they're in the system, they conduct those network scans. And I'll say one of the reasons why that is very effective is, unfortunately, for many organizations, they have a false sense of security inside their networks. And Sterling, again, will talk about this in some more detail, but this was very common in my experience, and both in the Bureau and now in the private sector working with companies. Many companies will have a great focus on their external sort of perimeter security when we're talking about actually, honestly, both physical security in the real world as well as cybersecurity. But then once you're inside that perimeter, the necessary protocols and safeguards are not necessarily as common because people have a false sense of security that they're keeping everything out. But the problem is that single, maybe it's a single device that they don't realize is exploitable because it's a 0-day and nobody knows. Let's a bad actor like the Strontium Group into your networks, and now because that assumption was made that people can't get inside, it's like the Wild West for them. And networks aren't segregated, and there's no access controls, and so they could just exploit everything. That happens. That is, I would say, almost more common than the alternate. So it's important both to not assume that your devices are secure without doing assessments, but also not to assume that your internal systems can all be connected without considerations that many of which the Sterling is going to go into greater detail. So I will stop so he can take his thunder on that. I did want to reach back to this point. I mentioned it earlier. The FBI specifically put out bulletins in April and in May of this year that organizations, specifically, PRC is targeting, as well as just general cyber malicious bad actors, are absolutely targeting organizations conducting any type of COVID-19 research. As Lauren was mentioning, often people think about, protection of assets that are hazardous or dangerous that can be used as a weapon. But when we just think about the intellectual property that we've been talking about in many of these organizations that had breaches, as well as in your organization, even if you have no hazardous material or material that could directly be used to make a weapon, you undoubtedly have lots of intellectual property. And in many cases, that's specifically what the FBI was noting are being targeted. If state actors who are looking to get intellectual property for a specific government to be able to use and get to market sooner, or just for bad actors to sell to parties that might want that intellectual property. So again, I'll reiterate, if you are working on COVID-19 research and getting any kind of media attention at all, assume you're going to be looked at by these types of bad actors. All right, so what can you do about all this? Sterling's going to go into greater detail on a lot of that, and we're going to talk at the end about mitigations as well. But the FBI put out some simple, straightforward recommendations that I'll go over now. So one, assume that any press attention you're getting is going to increase your risk of being attacked. Any activity on COVID-19, any press that you get, just assume that that's going to increase. Actively scan your web apps, your web applications for any unauthorized access, modification, or anomalous activities. That should be a process that you just continuously have regardless, but that is something that the FBI is seeing was effective given some of the attacks that were occurring in relation to the COVID-19 activity. Absolutely patch all your systems for critical vulnerabilities, and mentioned prioritizing timely patching for known vulnerabilities of internet connected servers. So the thing I want to mention with that, I mean, there is a period of time when a 0-day, which is again a vulnerability to that up to that point was not known publicly. There's a point where that 0-day will be patched because the company, let's just use Microsoft because it's one of the most common. When the Microsoft operating system, a 0-day is discovered, it's no longer a 0-day because it's been discovered, and Microsoft's going to patch it, and they're not going to mention anything, and they're trying to keep it quiet until they've got the patch out, because there's a period for once the information is released that, hey, this is a vulnerability, you need to update your system. Well, of course, white hats, as we call, the good guys on the cybersecurity side, they're going to be looking for that, and if they're active on it, they're going to be on top of it, getting the systems updated. But as soon as the white hats see it, all the black hats see it as well. And so it's a race to getting your systems patched as soon as you can. And so it's very important that when that you stay up to date on, for every system in your organization, that the vendors and the manufacturers and the software developers for every single system that you have, no matter how benign it is, especially if it's internet connected, that you have people actively monitoring all of those resources for updates and are quickly updating, because of a update comes out, and if you're a month behind, well, that's a whole month period where a bunch of bad malicious actors that maybe weren't as sophisticated now have access to that vulnerability and will start scanning. As soon as a patch comes out in a major organization, you could see, if you're looking for this kind of thing, you could see all the scans occurring for those vulnerabilities. So it's important that you stay on top of your patching. It's critical. Another recommendation from the FBI was identifying and suspending access of users that exhibit unusual activity. And this will cover a lot of different activities, somebody being exploited through more sophisticated means, but even individuals being exploited through social engineering and being outwitted, if you would, and to doing something they didn't mean to do. Having a process where you're monitoring activity to identify suspicious activity and intercede is very important, and will help a long way with that. Improving credential requirements. This is so important, and I'll just leave it at, from my perspective, when I'm giving any consultation, and when we're doing this at Merrick, we're helping any organization, and in my personal life for sure, multi-factor is not a nice add-on. It is an absolute fundamental requirement. It needs to be, it solves so many problems that exist right now with passwords in the world, that if we had universal implementation of multi-factor, it doesn't solve everything, of course, but it would take a massive chunk of vulnerabilities and avenues for exploitation out of the playing field. And it just takes discipline and training to use it. And so for me, multi-factor authentication on any system that matters at all is a requirement, and I would highly recommend it be one for you as well. Now, the Bureau encourages any victims to report any suspicious or criminal activity, of course, and there's a link here for how you could go about getting that information, for finding the field office in your jurisdiction to do that. They also provide the website cisa.gov/coronavirus. This is related specifically to the bulletins that I was mentioning about COVID-19 activity. But I will tell you that there is a limit to what the FBI and the federal government can do. I saw this all the time as a special agent, where I would have relationships with the life science organizations in my area. I was a special agent in New Jersey, and we would obviously be a contact for them. So once we built a relationship, if they had anything happening, they could reach out to us. But short of criminal activity occurring or actual breach occurring or something actionable, there was a limitation to what assistance that we could provide. We certainly couldn't give specific instructions on how to do an assessment at the granular level, or certainly not how to mitigate or what equipment to install, because for the government, there's a level of liability that they feel is incurred when they give specific instructions. So they're pretty much told not to do that, and it's quite frustrating, to be honest. If you talk to FBI agents, WMD coordinators, know that they want to help more than they probably are, but they're limited by those policies and regulations. So if you're looking for help and you want more granular assistance, that's precisely where we can come in and help you. So if you need additional help beyond what these, the Bureau might be able to provide, reaching out to Merrick and to GeneInfoSec, we're going to be able to provide you those kind of granular guidelines and recommendations and specific recommendations. So with that, I'm going to transfer it to Sterling, who's going to go into even deeper dive on the genetic information security and some of the things that I've already touched on. Sterling, on to you.
Nick, thanks to Lauren for that great introduction, and thanks to Merrick for having us here to talk to you about genetic information security. Right now, because of the pandemic, there's a big focus on pandemic information. And Nick, I might have you change slides for me. We'll start with a poll question. Which IT vulnerabilities are the biggest concern to your institution? Networks, devices, the insider threat, cloud security, or perhaps something else? And I'll launch this poll now and give everyone a little bit of time to answer. We are at most of the audience now. If anybody else wants to jump in next 5 seconds or so. So we'll close that poll, and it looks like it's a widespread. Half people are worried about their networks, half their devices, a third insider threat, and a third cloud security. So this poll allowed people to answer multiple choices, which is fine. It really shows that there's a large range of threats, and that it's good that people are aware, perhaps, of which threats their institution is most vulnerable to. Next slide. So for my part of the talk here, we'll be focusing on genetic information specifically. And genetic information offers a wide range of benefits, and advancing technologies are going to help us in a range of different ways. Right now, many people have done their ancestry tests, which are great. It's a great opportunity to find out more about your history and potentially find long lost relatives. But that same approach leads to a loss of anonymity, which means that it makes the data that much easier to identify, and it also makes an individual easier to identify in the field. Medical advancements using genetics are promising a range of wonderful treatments that are designed for your specific genetics. In the near future, we'll be able to predict with diagnostic prediction the types of diseases that you have a high risk of developing using almost entirely just your genome sequence. But that same information is very sensitive, it's very private, as well as it can be used in some ways to perhaps induce an illness, especially if you're not aware that you're vulnerable to an illness, but perhaps an attacker might be. And you might be an individual, might be a population, an ethnicity, or even a country. Then when we look to the more distant future and how biotechnology has these great advancements, including designer organisms, advanced vaccines like this Pfizer vaccine with using mRNA, really amazing technology is coming out. But as that biotechnology develops, it also makes it easier to develop bioweapons. And all of these advances rely on genetic information at its core to provide the advancement, and that genetic information then also becomes a potential threat. Next slide. So here we're going to now focus on how genetic information is relevant to the pandemic. And the pathogen sequencing was necessary for us to identify coronavirus, for us to try to determine its origins, for us to monitor its spread around the globe. Next slide. You could jump 2 ahead, actually. It's critical for the development of vaccines. As I mentioned, that Pfizer vaccine is an RNA vaccine, which means that it's using the actual sequence of the virus. It's not using the actual virus itself to give us a potential way out of this pandemic. And as Nick mentioned, there are a number of individuals and groups coming after our valuable IP. Well, what is that IP for that mRNA vaccine, except really the sequence of the RNA that they're using in this vaccine? So this technology that's developed to protect us is also very hot for adversaries to take advantage of today. And when we look towards the distant future, next slide, it's going to allow us to diagnose and predict diseases, and that has some issues when we start thinking about specifically who in our population might be vulnerable to coronavirus, and do we know if we are as individuals vulnerable, and are our adversaries aware of this information perhaps before we are. Next. And so to offer personalized treatment at the doctor's office is really necessary for us to advance medicine. Right now, we have a one-size-fits-all for our pharmaceuticals, for example, for the most part, but we are starting to see specific treatments that are only prescribed when you have a specific set of genes. So genetic information is not just very important today, it's of growing importance, and as the cost of DNA sequencing continues to drop, it will only become more commonplace to use genetic information, and consequently the attack threat the landscape will grow. Next. So genetic data is also identifiable, and this is key to anything that we want to do to protect our genetic information. We have to recognize that the data itself is identifiable. After the Golden State Killer was caught using just his DNA uploaded to a public repository to find his relatives, the public and the academics have finally accepted that genetic data is very easily identifiable. While we recognize this as a threat, the state of today is that we simply remove our names from the file before we share it, before we put it on the cloud, and that anonymization is just very, very weak in terms of protecting the identity of the individual. Next slide. And so this information is vulnerable if it's unprotected. The health information, as I mentioned, is sensitive, and the intersection between human genetics and disease severity is incredibly sensitive during a pandemic, because when we create our research around coronavirus, we're creating information that very much can be used for good and can be used to protect us from this pandemic and future pandemics. But unfortunately, that same information can be used potentially in the future to find vulnerable individuals, as well as design future bioterror attacks or bioweapons in a way that could cause us greater harm than this pandemic. And we've seen trillions of dollars in damage for what is not, it's not Ebola, it's not the most scariest disease in the world. It's very damaging, but what could happen with a scarier disease in terms of disruption to society and disruption to economics? And focusing on protection of genetic information should be paramount to protecting against these future threats. Next slide. So the costs of lab insecurity, Lauren touched on these a little bit. There is definitely the institutional reputation damage that can occur if you have a data breach, and you might not lose sensitive data. It might be the email addresses, for example. That's fairly common breaches that we see, where the institution will lose email addresses, but that does give your customers a second guess at maybe we shouldn't be sending them the genetic information if they can't handle security of email addresses. Then the other big cost that you might face is intellectual property, and I mentioned that the vaccine, that entire vaccine information is present in the genome sequence that they were using. So the DNA for our emerging biotech, for our academics, that DNA is the intellectual property, is the most valuable thing on your network, and should be addressed as such. Then there are regulations surrounding medical data. It depends on the organization. It depends on if they fall under any of these specific recommendations. If you're handling European human genetic information, for example, there are stiff penalties for losing that data. But with the growing attention to this area, we are expecting more regulations in the future, and your institution, your organization doesn't want to be the one that's called out by that senator when they're drafting new legislation as the reason why the penalties need to be so large for violations. Next slide. Now, when we talk about pandemic information, the cost of lab insecurity does rise beyond the organization. There is a risk to the bioeconomy for our biotechs, for our startups having lost their intellectual property. There's a big risk to biosecurity for our biosecurity labs if they can be attacked in a number of different ways, and that goes beyond just data being stolen. And this leads all of our health security to be at risk if we don't start addressing this problem. So this is not just an institutional issue, this is also a national issue and an issue for populations and ethnicities within nations, because there's legacy costs that could last for generations. Genetic data, for the most part, is yours for life. If your genetic information gets out there, you can't change your social security card, your social security number, you can change your credit card, and you definitely can't change your DNA to the extent that you would need to prevent these types of risks. And so these legacy costs might not just affect your institution or even your generation, it could affect generations to come. Next slide. So here's a simple diagram of how genetic data is generated to give us a sense of what we need to do to protect it. Genetic labs require a human element. The lab tech has to be in there to run the machines and to handle the samples. Human elements introduce an insider threat that might not be an individual that wants to cause harm to your organization. As Nick pointed out, the email phishing scams are a very common way in which networks are infiltrated. And with a human element, especially when they're biology focused, they might not have training in IT sufficient to prevent them from making a mistake. From there, our genetic information goes into, a genetic material goes into a sequencing machine which produces genetic information. This is one of the many devices in the lab that could then be hacked, they could intercept the information on the network as it's heading towards that lab computer or beyond. And then the lab computers, Nick mentioned, you need to update and you need to patch if the computer gets hacked or if it gets hacked on the cloud. All along this chain of information generation and transfer are potentials for the information to be stolen, damaged, or modified. Next slide. So Lauren mentioned these three things that are key: confidentiality, availability, and integrity, and we have to have all three of these things to have strong information security. If you lose your data, I mentioned that you can lose intellectual property, and we've discussed potential regulatory issues and loss of reputation, but the availability of your data is also critical. It's not just the data itself. If they can slow down your lab in some way, if you're competing to get that vaccine out there, well, if your lab can be slowed down by a couple days because equipment is malfunctioning and you can't figure out why, it could be stopped entirely and you might have to replace equipment, or equipment could be damaged. All of these things reduce the availability of the data or the availability of your lab to function. That leads to the integrity of your system, which you need to be able to trust your system to be able to produce the data that you expect it to be producing. And if your system has been infiltrated, there's at least the possibility that information could be damaged, and the system from there could be damaged in a number of different ways. You could, for example, if your refrigerator or freezer uses an Internet of Things device to regulate its temperature, it makes it easy for you because your phone maybe tells you when your freezer is having issues and when you need to run back to the lab to make sure your samples don't get damaged. But that same device could be an entry point into your lab, as well as a device that could be used to damage your samples without necessarily your phone being alerted that your freezer is temperature is rising. Next slide. So this will be my last poll question, and we are interested to learn when the last time you examined your network for information security vulnerabilities. So I will launch that poll now. And that was pretty quick for most people to answer. Give a few people a few more minutes. And thank you for answering so quickly. Well, This is a very interesting split because it's essentially a 50-50 split between less than 6 months and don't know, never examined. So some people are doing the right thing. You need to examine your entire network and the devices within it for vulnerabilities at least every 6 months. And if you don't know when it's been examined, it might have been examined by your IT professional. It would be great to ask them and make sure that they're staying on top of things, because it's a big job to really go into the network and look for vulnerabilities. Next slide. So how secure are the labs that are out there? We sent a team in to find out and to figure out what can we see in the field. Next. Working with the University of Colorado, we performed digital data security assessment, examining a wide range of IT security in different labs, academic, for-profit. We did surveys, we walked through the labs to examine what was going on, but we also probed networks and examined devices for vulnerabilities. And what we found was that because biologists just don't have the necessary training, unfortunately, insecurity is the state of the art surrounding genetic information. Next. So everybody has some type of safeguard in place, right? Everybody uses passwords or has some type of physical access control. The problem is that the safeguards that are put in place are often inadequate. The passwords are weak. They'll use sticky notes to display their passwords in case they forget them. They might have physical security, but it's not sufficient to deter somebody who may be, looking to get into the lab and have some type of capabilities to sneak in, for example. The device insecurity we found was the biggest problem. Internet connected devices are just all over the place. Some of this can't be helped. Some of these devices need to be connected to the internet. But when a device needs to be connected to the internet, it's important that it is hardwired. There's an over-reliance on Wi-Fi connectivity. These devices often have the capability to be hardwired. And when you're using Wi-Fi, it just adds an additional entry point to your network, as well as a method by which an attacker that sneaks into your network, perhaps through a printer, can then hop around the network to whatever devices are on that Wi-Fi. Now, device security relies on the device manufacturers. Nick mentioned that you have to patch. If a 0-day comes out and you sit on it for a long time, you're vulnerable until you patch that 0-day, and all the black hats are going to be aware of that vulnerability and could be looking to use that against you. When it comes to device security, unfortunately, for the majority of these devices, you as an institution do not have control over the software that's on that device. So you need to talk to these companies to make sure that they're updating these devices. And in some cases, it does require a lab tech to come out to update the devices, which creates a big problem for keeping these devices secure. Some devices are frankly just impossible to secure. You could call up the company that produces them and they would say, just take it out of your lab. We're not designed to be put into any sensitive environment. And other devices are just necessary for your operation. You need a DNA sequencer in your lab. You need these analytical tools in your lab that have to be connected to the internet. But they're going to have vulnerabilities, and so what can we do to protect our IT infrastructure if we know we have insecure devices? Next slide. Well, the first thing that we can do is try to go old school. So new school devices like an Alexa and a Roomba, they save you time, they make your life more convenient. But these old school devices, they are foolproof. You can't hack into a boombox. There's no way that an attacker is going to use your mop or broom against you. But not everybody can go back to the boombox. Maybe we don't have enough old tapes to be able to listen to enough music to keep us entertained. So we want to go new school, and we want to have that new technology in the lab, which is understandable. But by chasing the latest and greatest technologies, you could very well be creating vulnerabilities immediately. And it's important before you put any device on your network that you do a security audit of that device. It might require you going beyond just talking to the company that sells you the device who might think that in their, they might have their best interest and yours at heart, thinking that that device is secure. But if no one has really looked into it, then there's a chance that that device will have vulnerabilities. And then even if it's shipped to you and it's not vulnerable when it's shipped to you, how is it updated? When is it updated? Who has the ability to update it? So if you can go to the non-Internet of Things device, we recommend using things that are not connected to the internet where possible. And when connecting things to the internet, please use hardwire instead of Wi-Fi when possible. Next slide. So we start talking about advanced devices, and the more advanced the device is, the harder it is to secure. The more pieces are in there, the more pieces of hardware are in there, the more firmware it has, the more software that needs to be updated. Then when we look to the device itself, we often find that the USB ports, for example, are easily accessible on the device, that the Bluetooth keyboard is so easy to use, and you really want to use that Bluetooth keyboard. But if somebody has physical access to your lab, Bluetooth is a method by which they can gain entry into a device and through that to your system, just like an open USB port. So these device vulnerabilities can take a long time to be fixed by a company. In some instances, you need to buy the newest version of the instrument to actually have the security. And this is just something that we have to consider as being part of the ecosystem that we're dealing with when we're working with laboratory IT security. Next slide. So our recommendations for addressing these problems is to figure out which devices are insecure. Have external audit, if necessary, come in, probe these devices and probe your network to find out which devices could be problematic, which ones are not updated, which ones can't be updated. From there, it's very important that you partition the network. We have sensitive genetic information, as we mentioned, very critical to keep secure. You want that, frankly, on a separate network from the rest of these devices. You could firewall it off. If you know what you're doing with a firewall, it is potentially a fix that you could stay on top of and be a potential solution. But a better solution is just have a completely different network, completely different entry into your network, so that these devices that might play our music or operate the freezer temperature are entirely separate from any network that handles sensitive information. And from there, maintaining good general information security is key, and that requires us to all work together to stay on top of what good practices are, to train your employees. And then from there, I'm going to pass this off to Lauren to discuss more of what we can do to keep ourselves secure.
Thanks, Sterling. So in terms of mitigating threats and risks, how do you actually do it? Next slide. First step, as we talked about, I think fairly thoroughly, a holistic and comprehensive biorisk management assessment. So we talked about all of the pillars, everything from material security to physical security, transport, IT. Look at all of them. Make sure that you're not just focusing on the ones that are of the biggest concern. And then take a look at those factors and think about the potential mitigations. And pick the ones that give you the biggest bang for your buck. While some things might seem like a great idea and are pretty fancy, and I know everybody looks for the best widget to solve the problem, make sure that whatever it is actually addressing the concern that you have. Next slide. Have these documents. If you don't have them, create them. It's always good to know what the expectations are so that you know when you're deviating from those expectations. Having them written down and able to be reviewed by people who understand what they're talking about or people who are doing them is really important to make sure that we call out those areas that are potential hazards or risks. Next slide. So back to the pillars. Physical security, secure your sensitive material, know your procedures for screening people and items that come in, layer your security, and Sterling and Nick both talked about this in terms of data security, but it's also true for physical security. You want to have different layers that add on top of one another to decrease your risk. Establish signage, potentially badging, depending on where you are, and then have alarms on any point of access control. So before we skip on to the next piece, I just wanted to reach back to the two of you. And Nick, do you have any lessons learned or recommendations on some of these physical securities that cross over into the digital space?
I had to unmute myself there. Yeah, absolutely. So as I think we've mentioned, and I know we're going to keep going back to these all cross pollinate. They all affect each other. But one that I'll mention that is probably the first thing I think of and the first thing I address when I'm going into a facility that's we're assessing and we're assisting is when you're talking about access control and just physical access control. Some organizations actually think about the fact that access to server rooms that's actually needs physical access. Like they often will think, well, we're working with Ebola, we're going to secure. There's because of the regulations, they have access controls to actually get to that material. But some of them don't think about the fact that access to the server room or to other workstations that impact the access control to their biological agents also need to be protected at the same level as the direct access, because like we mentioned many times in those examples that I talked about earlier, that bad actors are patient, and so if they need to compromise one system that's easier to get to, that will eventually get them access to the ultimate goal, that they'll do that. So the principle of I guess the transitive property of secure materials going all the way through any kind of access, and information technology access is the most, it can be the most difficult to see because it's not right there in front of you, and you don't realize that, hey, that building that's 500 meters away from the lab with the biological agent also needs to be secured. So that's one that I see often.
I mean, I think that's a really good point. And while we certainly don't think about it in practice, it's something that shows up on every adventure movie and oceans movie I've seen. So good point to keep that to the forefront of your mind. Sterling, from your perspective, you talk a lot about the firmware, the hardware, equipment pieces, and the security in the way that they tie into networks. Do you talk about layering in terms of that security and integration into the larger systems?
Definitely. The layering is in a way, partitioning the network is in a way layering the system. And as Nick mentioned, the information created, you want to protect access to Ebola physically, but protecting the genome sequence of Ebola is looking to also something that's important. So when you layer things, a good example of this would be to have a different network for guests to come in if they want to be on Wi-Fi. That could be your external layer, so that in the waiting room they have access to the internet. But you definitely don't want that to be the same network that you're operating your lab on, and definitely not the same network that you're handling sensitive information on. So you can have multiple layers of access on the network itself to better protect the information, the sensitive information that you're creating.
Absolutely. Thanks for that. Next slide. We'll skip on and talk a little bit about personnel management. I know we talked earlier about the personnel reliability programs, but I think there are a lot of different things that you can do to understand the security of your personnel and their behavior, even after the first time they walk into your lab, and maybe when you screen them initially. It's important to be consistent in that application of personnel management. Is there something that perhaps, Nick, I know you talk a lot about personnel reliability and threat actors. Is there something that you can talk about as it relates to IT security? Are there flags that you consider indicators that the IT security team might be able to look out for, that they should be able to communicate or know that communication is important?
Absolutely. And this, again, it's going to sound like, it's going to sound similar, a lot of these, because they are really so interrelated. This common thread of how these all really lay as like one concept over all these different different modules: physical, personnel management, IT, and so for PRP and for personnel management, you know, you have hiring practices where you're looking to get the qualified people and people that are appropriate for your program, but I would contend that the probably most, well, it's all important, but one of the most impactful aspects of a personnel reliability program is the continuing evaluation aspects, because it's more in line for people to think about, you know, through HR hiring quality employees, but oftentimes it just stops there. And part of a PRP is a continuing evaluation aspect. It's a major aspect of it. And what that's doing is that's looking for behavior and things that have happened in individuals' lives who have access. So you're really trying to, you're really looking at people who are going to be considered insider threats. And an insider threat being an individual who is supposed to have access to whatever you're trying to protect. So let's just keep it to the IT side, you know, you have individuals who have access, you know, a system administrator. There's very little, very few individuals in an organization that have as much power to cause problems for the topic we're talking about than a system administrator, and they're often overlooked by organizations executive level, unfortunately, for the power and vulnerabilities that those positions have. And so both for, you know, a PRP should include individuals who are directly accessing materials that are valuable, physical materials or data, but they also need to include the people that control access, so the system administrators and IT staff. And so in a PRP, what you're looking for, a well-designed PRP is going to allow the individuals in the organization that are a part of it to continuously evaluate individuals. So we don't have the time to go into all the mechanisms, but from a standpoint of an IT, like you said, Lauren, what can they look for? We mentioned it a little bit from one of the FBI's recommendations is, you know, scanning for activity in the network that is unusual. So you build a baseline when you first bring people on, and you have a baseline from what people are supposed to do for their job description and whatever their tasks are. And so, for example, if you have an individual who is normally from 9 to 5 accessing certain systems at a certain rate, but then all of a sudden you observe, because you're looking for it, that they're starting to access the systems. Maybe it's the same systems, maybe it's systems they are legitimately supposed to be accessing, but now they're accessing them at you know, weird hours, off hours, middle of the night. And a PRP is going to enable the organization to evaluate that, look to see what's causing that. There very well could be a legitimate reason, and that could be accounted for and included in the baseline for what's acceptable. But it might be indicative of activity that while not directly a violation, like they might not be hacking into the system. Maybe they're having problems at home, and they've become an alcoholic, and they're just trying to come to work all the time. But that's just a one example, right? That might be the thing they're doing in the middle of the night isn't even necessarily nefarious. They're just working to stay away from home because of a bad situation. But that might start to indicate that they're susceptible for exploitation by bad actors. Maybe they have money problems because of these issues that I just described, and so then they're vulnerable for bribery. So a good PRP is going to look at all of those things and provide a way to, on a continual basis, to look for those types of flags.
Yeah, and I think this stresses a point that we often talk about in terms of integration of your entire team, from your facilities department to your IT folks to your science staff, and making sure that everybody understands what right looks like and what normal looks like, so that they can alert the appropriate people when that steps outside of the norm. The other thing I'll say is, in terms of personnel management, making sure that people understand the expectations so that they don't become that negligent insider because they don't understand how they're supposed to use their networks. If they have Post-its with their passwords, like Sterling mentioned, that might be because nobody's ever told them that that's a bad idea. It's possible. There are a lot of people who aren't quite as well versed in IT security as we would guess. So I think making sure that this extends to training and expectations management is really key. All right, next slide. So material control and accountability, decide what is restricted material, figure out where it is and how much you have of it, try and consolidate it to areas so that you can easily monitor it, and then develop a policy to determine when you don't need it anymore. Continuing to maintain information or materials that are no longer necessary is an unnecessary vulnerability. Next slide. So transport security, this is pretty similar. Create a policy and procedures for any unexpected shipments or processing and handling requirements for expected shipments. And make sure that individuals who have responsibility for moving things around are screened to do so. And then keep in place those approvals for movement of that material. So there's a substantial amount of data that surrounds the transportation of these biological materials that we wouldn't normally think of as part of information security. So things like information exchanged on materials to be shipped or received, ordered, that kind of thing. Are there any things that the two of you have noted as aspects for consideration when you're thinking about data security for movement of materials?
Yeah, I mean, one thing I'll mention, or two things, I suppose. One is just the concept, and this again, it crosses multiple. This crosses over material control and accountability with transport security. But having a chain of custody, having that be something that's specifically delineated in your policies and SOPs, so that you first just do know who's involved in transfer of physical assets, but also that crosses over to transfer of data. So it's just a process of being precise in your knowledge of who is impacting transportation of data and or physical assets, is something that is oftentimes lacking enough precision and enough detail. But when you do get that level of detail, if you're not safeguarding the confidentiality of that information, you're at the periphery of transportation, you're getting farther away from things that you can control. Your individuals that are not part of your company interacting with your company or your organization. And so it's just inherently more, less that you control, inherently more vulnerable because of that. And when you have the individuals that are involved in your organization at that interface are more vulnerable for attack, because again, they're looking for the avenue of least resistance. The bad actors are looking for that. So it's important to protect the confidentiality as much as possible of the identity of targets, of individuals that a bad actor could identify through sending a shipment to a place and finding out, send a shipment to your organization and find out who's involved in receipt and seeing if they can exploit that individually. Bad actors absolutely target individuals and organizations. They don't just do that. They'll usually start with a broad spectrum, scanning of vulnerabilities, but they will look to pinpoint specifically vulnerable individuals for various factors of their experience, their life situation. They'll absolutely, especially state level actors will then, once they identify a person, do workups on the individual to see what's the best way to exploit them. And individuals at that transportation level at the periphery, as well as the individuals and other organizations that are interacting, are targets. And so protecting the confidentiality, as well as now crossing back over to personnel reliability of having processes for safeguarding that, they're all tied together, and it often is overlooked because it's not something that it either happens a lot and it's not thought of because you're often getting things in and it's very benign, or you don't even get a lot of transport and it's an area where it's not really considered.
Yeah, I think that's your point to the importance of integration. I think we harp on this a lot, but it's pretty important. And sometimes those folks who are doing the procurement or who are receiving materials aren't necessarily going to be those that you automatically add to your list of people who need to be trained in these things.
I would add, when transporting information, the most secure way to do it is with an encrypted hard drive physically. So It's something that most people don't recognize in the age of the internet. We think we'll just upload it onto the internet. But if you have an encrypted hard drive with a secure key exchange, then the attacker would need access to the hard drive as well as knowledge of what the key is. And so if you're handling sensitive information and you want to keep it secure, look into how hard it is to mail a hard drive, because frankly, it's not that difficult, and it offers a lot of protection when transporting information. So just wanted to.
That's a great point. No, that's a great point. And we've had a couple of institutions who manage their data in that way when they need to share information that might be sensitive. And so I think understanding the controls around even the transport of data is incredibly important. So thanks for that. Next slide. All right, so we went through all of this. I'm just going to review it quickly, but manage your passwords, two-factor authentication where it's possible. Keep those systems updated. Don't wait once they've turned out the patch. Go ahead and make sure you update everything. Scan your network frequently for vulnerabilities and know which devices are insecure so that you can put in place the appropriate barriers, whether they are separate networks or firewalls, and just maintain good information security. All right. So, recommendations. Conduct a comprehensive biorisk assessment with all those pillars. Have a mitigation plan in place with appropriate personnel to actually perform those mitigations. So make sure they understand and are the right people to do it. Don't assume that genetic data is protected. It is identifiable. Don't expect everybody to be aware of threats, and reach out for help if you need to. So we've finished up with about 15 minutes remaining. If there are any questions, we'll go ahead and leave those in the chat or in the questions box. We've got one so far that says, when and where will the presentation slides become available? After this, we will we'll package the recording and we will post it on the Merrick website. If you registered for this webinar, then we'll go ahead and send out a link to it, but you will be able to find it on the Merrick website. Any other questions? Give people a couple of minutes. I really appreciate everybody joining us today. I know that this is everyone is experiencing some degree of Zoom and online meeting fatigue. So really appreciate you joining us today and hope that this has been useful. If it hasn't covered some of the questions that you were hoping that we would discuss, please feel free to email us. You can screenshot those or just kind of look on Merrick or GeneInfoSec, and we're available, happy to help at any time. So on that note, we will go ahead and end a little bit early. Thanks again.
Thanks,
everybody.
guys.
Take care.